Okay, let's take a look at application whitelisting and the macro attack. First, I'm going to open up gpedit.msc on this test system, and we're going to use the pretty lame application whitelisting that comes with Windows 7. So let's go to user configuration, administrative templates, and then finally system. Let's come down here to run only specified Windows programs. And I'm going to resize this a little bit. Let's enable it. And let's add a few applications to our whitelist. WinWord.exe, Internet Explorer.exe, so iExplorer.exe, and Explorer.exe. And that's a pretty minimal whitelist. It'll do for now. Just make sure I don't close this program, or else I'm not going to be able to undo it. Let's verify our whitelist works, and it does. If we try to open stuff not in the whitelist, we get an error. Cool. Now, let's go ahead and set up the macro attack in Cobalt Strike. For this one, I'm going to take the phone a friend option and jump over to a Windows system and connect to my team server with a Cobalt Strike client on Windows. So we're going to go over to ads.losenolove.com, press connect, and here we are. We're now connected to this internet-based team server, and from here we can generate a malicious Word document with a macro in it. Let's go to Attacks, Packages, Microsoft Office Macro. Choose the right listener, press Generate, and there we go. These are the steps we need to follow to embed our macro into a Word or Excel document. So let's go ahead and copy the macro to the clipboard, open up Word, and say, this is my resume. Please click Enable Content to see it. And we'll even highlight that and make it look nice. Cool. Now let's go to View, Macros, View Macros, and let's type in a bogus name like blah and change macros in to document1 document. Press Create, clear the code that's there out, and then go ahead and paste in the macro from Cobalt Strike. This macro is derived from the macro in the Metasploit framework contributed by Matt Weeks, Script Junkie. And Matt's macro is pretty novel because it injects directly into memory. This one modifies it slightly for obfuscation and to account for if you're in a 32-bit or 64-bit office, and in either case, spawn a 32-bit program and inject our payload stager into it. And the value of this is the attack is now agnostic to a 32-bit or 64-bit office. And if the user closes the document, we're still up and running. So let's go ahead and close that. And let's save our macro-enabled document. We'll put it on the desktop. And we get two choices. We can save it as a Word macro-enabled document, which is a docm extension, or a 97-2003 document, which can be a .doc extension. I think you know which one I'm going to do. So let's go hit save. Looks good. Now let's go ahead and upload that to our server. We'll grab it off the desktop. And we'll do ~rafi resume.doc. Of course, always use a redirector or a fully qualified domain name. Hit launch, and there we go. We've now hosted our weaponized Word document. Now let's go ahead and download it. ads.losenolove.com, ~rafi resume.doc. Let's open the file up. Enable editing, click Enable Content, and there you can see, even with the little bit of application whitelisting, we're still able to get an access on the system with the macro attack. Okay, let's talk about egress restrictions and restricted firewalls. The defense, limit which protocols may leave the network. As the attacker, you have to communicate over the allowed protocol and make sure you're using valid traffic. It gets a little bit tougher than that. In a moderate to hard environment, here's what you're going to see. First, a moderate to hard environment is going to deny all outbound traffic, period. Okay? When I work on an engagement, this is my operating assumption. I don't assume it's any other way. Any egress that happens is only going to happen through a proxy device. The proxy device is going to inspect traffic to make sure it conforms to the expected protocol. It is very possible that the proxy device is also going to require that the client that's making the outbound connection authenticate with the proxy server in some way. Okay? Now, one limitation we, the attackers, have dealing with this stuff is staging. I've talked about payload staging before. That's the idea of a small stub of code downloading our payload and injecting it into memory. Payload stagers are size constrained because many of the attacks limit how much payload stuff we can send with them. So smaller is better. The smaller a stager is, the more attacks we can use it with. Also, if a payload cannot stage, then it can't execute. So if a protocol works for staging, command and control over that protocol is okay too. So how can you defeat restricted firewalls with Cobalt Strike? Well, let's talk about the stagers included in Cobalt Strike right now. The HTTP and HTTPS stagers are pretty cool. They'll use the Internet Explorer's proxy settings for the current user. So if you're running in a user context, which would make sense if you got on the box with a phishing attack, you'll probably be able to get out through their proxy. Any kind of automatic NTLM authentication is definitely okay. One thing these stagers do is if there is a proxy authentication error, they will prompt the user. Some environments are set up to have a separate username and password for the proxy server, and the user has to put that in. The good news is they've been trained to put it in because other applications prompt them in the same way. The beacon stagers happen to use the same prompt as Internet Explorer. What about the DNS stager? Well, Cobalt Strike's DNS stager, like I said, it uses over 1,000 text records to download beacon, so it's a little bit noisy. But if the target can resolve names, then there's a good chance you can probably get out and deliver the DNS beacon with the DNS stager. Okay? There are going to be many times that you're going to have to operate on systems and in contexts that cannot reach the internet. For example, if you elevate, okay? And if you elevate in such a way that you end up in a system context, that system level process is not going to have the information it needs to authenticate with a proxy. Just simply won't. And there's going to be systems where it's neither a good idea for them or they just simply cannot reach the internet. For those hard to reach places, use the SMB beacon. Okay, let's talk about active defenders and hunt teams. The purpose of a hunt team is to actively inspect traffic and host behavior to look for suspicious activity. They're not trying to look for known bad. They're trying to look for the unknown bad. As an attacker, if you're going to go up against these folks, you need to operate in a way that blends in with legitimate activity. So let's go ahead and go through a few things. Beware of staging, okay? Staging is a limitation, and the small size of the stagers makes it really hard to do anything about those limitations. So if the staging process is getting caught, make sure you use the HTTPS beacon instead of the HTTP beacon. But if you do so with a legitimate code signing certificate. Don't skip on that. If that's not good enough, what you're going to have to do is use a stageless artifact. Go to Attacks, Packages, Windows Executable S, and you can export beacon in a variety of formats in a big self-contained file. Okay, let's talk about network security monitoring. First, make sure each piece of team server infrastructure has a different malleable C2 profile. I would put my best profiles on my long-haul infrastructure so you could blend in as best as possible for your persistent callbacks. Your post-exploitation servers should also have good profiles. The staging servers assume that those will get caught. So for your staging servers, I would use a really crappy profile. When you get caught on a staging server, you want the hunt team to look at it and say, wow, these guys aren't that good, and have them look for those indicators elsewhere, clean it up, and call it mission accomplished while you're operating low and slow with your better indicators elsewhere. As much as possible, you want your infrastructure to look legitimate. If you can, host your redirectors on different providers. Don't just put redirectors in Amazon's Elastic Computing Cloud. Buy VPSs in Linode. Buy them in Rackspace. Put them in EC2 as well, but try to diversify as much as possible. Also, keep in mind, domains are like fine wine. They get better with age. If you try to attack a network with a domain you registered last week, chances are something sophisticated is going to flag you. The same applies to phishing. Domain age is a big indicator in anti-spam measures. So if you can, get a bunch of domains and hold on to them for a very, very long time. The other thing that's going to help you is the common sense operate low and slow. Use Beacon with as high of a sleep interval as you can tolerate and as low of a sleep interval as the target environment will allow. Going along with that, you should pay attention to your communication paths. You should pay attention to how each target you interact with is communicating to your infrastructure on the internet. So here's a few tips with that. First, servers should not ever egress and connect directly to your team server infrastructure or redirectors. You can make a case for DNS beacon being okay, but I would never let HTTP or HTTPS beacon touch my infrastructure from a target server. The other thing to pay attention to is using the SMB beacon to go from a server to a workstation is, well, weird. So be aware that that's weird and avoid it if you can. The other thing about communication paths, or maybe this is more of a network security monitoring thing, but if you can avoid it, I don't recommend that you scan to find targets. And if you do scan, maybe do a very targeted scan in as small of a range as possible with 1 or 2 ports. That might be okay. What should you do? What are my tips on communication paths? Well, make sure you try to egress from user processes on workstations. Don't try to get out to the internet from a system level process. It probably won't work. Going further with that, if you're going to interact with a target, a server target in a network, try to do so from a workstation that might plausibly actually interact with that target in the first place. Remember, the goal is to blend in. The SMB beacon is a big ally in doing this. And very common sense, use the SMB beacon to go from workstations to servers and to control servers via different workstations you have footholds on. And when you're trying to look for targets, I really recommend using Windows tools that are built in or tools that map very closely to Windows APIs to find targets. Here's some tips to deal with host monitoring. I don't recommend that you change system configuration. That includes adding users. I am allergic to adding users. I also don't recommend that you put files on disk. As much as possible, avoid it. If you can, avoid creating services as well. You'll notice several Cobalt Strike features do it. GetSystem does it, PSExec does it, PSExec PowerShell does it. If you can, avoid it. Also, try not to put a beacon on every system. If you don't need to control a target with malware, don't. That's why in lateral movement, I spent so much time showing you how to use other tools built into Windows to control a target rather than using my expensive software that I want you to buy. Finally, I can't emphasize this enough. This is repurposed from the first lecture on operations. But I really recommend that you diversify your infrastructure. Have staging servers where you perform the initial callbacks, where your attacks are hosted, and expect these servers to get caught very quickly. Because you expect them to get caught quickly, do not put the same level of effort into making these look legitimate, because they are going to get caught. Give a blue team an easy win and let them think that they're dealing with an actor who's working at a lower level of sophistication. That will buy you a lot of operating room. I recommend you do post-exploitation from servers, dedicated post-exploitation, and never ever do post-exploitation from a long-haul server, a server designated to receive low and slow persistent callbacks. So as we're getting to the end of this presentation, I want to ask, do you remember this slide? This slide is the one I showed at the end of part 3 of this course when we talked about targeted attacks. In part 3 of this course, I took you through the process to get a foothold in a modern enterprise with Cobalt Strike. And I mentioned there are several wickets you're going to have to deal with. And you also notice we just talked about each of these just now. So to conclude this presentation and conclude this course, here's the summary of my advice, okay? To deal with the anti-spoofing measures in the email, don't spoof protected domains. I gave you the commands to run to check if a domain is protected or not. To deal with antivirus, Cobalt Strike's attack packages will get you pretty far in a lot of situations. The Power Applet with a code signing certificate is still pretty nice. The Office macro is still pretty effective as of the time this presentation was cut. Deal with application whitelisting. Use attacks that inject directly into memory. Cobalt Strike's applets do this, and so does the macro attack. And anything that uses PowerShell to get a payload in memory injects directly into memory as well. To deal with network security monitoring, communicate low and slow, blend in, and really take care to stand up effective, plausible infrastructure. To get out of a lockdown firewall and proxy configuration, egress over HTTP, HTTPS, or DNS from a user LAN process, and choose the protocol that's most appropriate to your situation. So in this lecture, we talked about the anti-spoofing measures in email. We talked about antivirus, application whitelisting, restricted firewalls, and how to deal with active defenders. This concludes part 9 of Advanced Threat Tactics and concludes the course overall. I hope you've enjoyed it. It has certainly been my utmost pleasure putting this course together for you. And go out, go forth in the absolute spirit of this tool set and this information, and let's make the folks who do network defense, let's make them better. Let's raise the bar, and let's make this industry better. That's what it's all about. Thank you again, good luck, and happy hacking.